Writing solution sets for SLEs is pretty straightforward, so let's get into it. Now there are three types of solutions that you can get. You can get a unique solution, infinitely many solutions, or you can have no solutions altogether. So when you're writing unique solutions, of course you solve for the equation, you figure out the values you have, and if it's a unique solution you only get one value for each coordinate, and you write it as such. Now infinitely many solutions, it's slightly different. The first thing you want to do is rearrange to include any missing values. Now not just for these two equations, but a third equation to account for the missing third equation that we need in order to gain a unique solution. So you can already tell something has infinitely many solutions if there are less equations than there are the number of variables. So if that's the case, make sure you put in a row of zeros for each variable that is missing. So as you can see, you've got a row of zeros to represent, the third equation that's not here. We clearly have three variables. So, the basic ones will be easy to spot, but the free variables are often ignored. Writing this as an augmented matrix gives you a visual of all basic and free variables, which is why you need to write down all the missing equations. Of course they're not actually missing, but that's why they're enclosed. Now, what we do when we have a row of zeros is that we just let that variable equal to itself, because it can be anything. It's a free variable, it's free roaming. So you could have four variables, x, y, z, t, and the same rule follows. So we let z equal to z, and then we solve accordingly. So we see that equation 2, y becomes minus z, equation 1, x equals minus y, and we have solved that y equals minus z, so x is just equal to z. So our solution set will look like this. So our x is equal to z, our y is equal to minus z, and our z is just equal to z. And always at the end, this means such that z is an element of all real numbers. So after you've done that, it's great. You think, okay, I did that, but augmented matrices, you're bound to make a mistake. So just double check that it holds, have a think about it, see if it makes sense, and yes, it does make sense. So when not to write a solution set. So if you see something like this, it's telling you that 0 equals minus 29, which is obviously wrong because I shouldn't have to explain why. So this is an inconsistent solution set, and so there are no solutions. Same thing here. If you see that there are two values for one value, that's just not right. Because if you rearrange it, so if y can be two values at once, so 36 essentially equals minus 29, which is the same case here. It doesn't make any sense. So, in summary, a solution set writes down all possible solutions to an SLE. Sometimes there is a unique solution, so we can just write the values, and sometimes there are infinitely many solutions. We gather this from if there is a free variable present, in which case we write down the basic variables in terms of the free variables. Lastly, an inconsistent solution set can be identified through the examples shown above. And that's it. Now the last thing I want to leave you guys with is that it is very important that you remember that the amount of variables, if there are less equations than there are the amount of values, then you're going to have infinitely many solutions. Alright, thanks for listening guys.